Awesome. Yeah, I'm looking forward to sharing it with y'all. So very first thing, while we're still kind of waiting for some people to stream in, I'm going to share a link with y'all. I hope that you're all like very excited to be a part of this. I know that I am, and I hope you're looking for more ways to get involved in the Polkadot ecosystem. So I just shared a link to our upcoming community conference, December 3rd. So please go ahead and register for that. My name is Dan. Thank you for the great introduction, Anthony. I am not a developer at Parity. I'm a developer advocate. So I am trained as a software engineer. That's definitely my background. I identify as a developer, but nowadays I spend a lot of my time writing code. Sorry, I spend a lot of. I was just seeing more tech issue there. I'm going to close my chat so I don't get distracted again. I spend not so much of my time writing code and more of my time helping other developers write code, helping them understand how to write Substrate code. And so that's what we're going to talk about today. Mork, to respond to your question about telemetry, I'll let Anthony handle the technical stuff, but I did see you had a question about telemetry. In my experience, I had to wait for my node to get fully synced with the network before I saw it appear on the telemetry site. Other people told me this wasn't the case. I don't know if I'm convinced. Maybe check in our Substrate technical chat to see if we can get a more clear answer on that. But the short answer from me is that if you're not seeing it right away, it's not a big deal, because I think once it syncs, you may end up seeing it. That was my experience. Okay. I'm just looking at the chat, Anthony. Is my video okay for you?
Yeah, perfect.
Okay, cool.
The presentation hasn't come up yet, but I presume that's by design.
I was just, yeah, I think so. Hope you're able to get the answer to that question, Mork. I hope you saw that. And just kind of a little more introduction to me. Yeah, I think the main thing I want you to know is that I'm a software engineer that really likes helping other people write code. So without further ado, let me go ahead and share my screen, and we'll just get right into our presentation today, talking about Substrate. So the kind of byline of this presentation is building blockchains the easy way, and I hope that this group is aware enough of the intricacies of building a blockchain to know that even the easy way of building a blockchain, there's a lot to talk about. So let's dive right into that. We'll start out by talking about like the company that I work for, Parity Technologies, why we do what we do, kind of the man behind all of this, really the brains of the operation, if you will, is Dr. Gavin Wood. He was one of the founders of the Ethereum network, and through his experiences with that, he started imagining what comes next. I think we all know and love Ethereum as like an amazing platform for smart contracts, but there's more that blockchains can do. And so early on, we're building infrastructure, blockchain infrastructure. You probably are familiar with the Parity Ethereum client that we kind of started out building. But nowadays the Parity Ethereum client was written in Rust. That's what we write now. But what we're implementing these days is not so much stuff for the Ethereum ecosystem, but more research that's coming out of the Web3 Foundation that Gav is helping to steward with the PhDs and researchers at the Web3 Foundation for the Polkadot network. And so the Polkadot network, we're going to talk a lot more about what it involves exactly, but it's basically a network of blockchains. So it's an ecosystem that involves a lot of blockchains and describes a protocol that allows these blockchains to scale, not just technically in terms of throughput and transactions per second. All that is covered, but there's also a lot of the more squishy issues of scalability in the decentralized world, namely decentralized governance. And so we're going to kind of dig into all of this as we go through this presentation. This is to kind of start to say that we have a really awesome community. There's these kind of like GitHub stars that are, they may seem a little like a braggadocio, if I can pull out an SAT word. That's what we do here in the United States for education. But yeah, this is to say that we have a lot of people building on our technologies, and I'm happy to be a part of the ecosystem. So today we're going to talk a lot about the technologies, but as I kind of mentioned at the beginning, I really hope that this kind of gets you excited enough to attend Polkadot Decoded, get involved in our technical chats, and really this is just the tip of the iceberg, what we're talking about today. So this is a technical depiction of what a Polkadot-like network can be. And so let's start by talking about the relay chain. The Polkadot network, the blockchain that's run by the Polkadot client, is a relay chain. And within the Polkadot protocol, these are sort of the infrastructure chains that provide shared security and message passing capabilities to the parachains, the side chains, if you will. And so whereas the relay chain may not really provide much exciting capabilities on its own, it provides the infrastructure that allows the parachains to come along and implement their business logic in a way that's cryptographically secure without having to worry about all the validators that's going to run that network. The relay chain takes care of the validators and all the kind of nuts and bolts of the crypto economic security guarantees. And then the parachains can just kind of hook into that and write their own custom blockchain logic using Substrate or other frameworks, but today we're really going to focus on Substrate. Let's dig in a little bit more into kind of some of the details of this, but really the main thing that you need to take away from this slide is that this is an ecosystem that's comprised of many blockchains. The rest of the stuff that I'm going to say is kind of just icing on the cake. So just keep that in mind because it can feel like a lot. So we have parachains, which are blockchains. Many of them are written using Substrate, the very same framework that we use to write the Polkadot relay chain. And whereas the Polkadot relay chain is providing this kind of boring infrastructure, the parachains are providing more of the interesting application user-facing business logic. The relay chain is supported by validators. Those are what the nodes are called that author blocks on the relay chain. And on the parachains, we call those collators. So that's just kind of a bit of jargon, a bit of terminology. You may have heard about like a parachain auction as something that happens in a Polkadot-like network. And so that's like a commitment process. It's one of these squishier aspects of scalability. In order for things to scale, there needs to be some expectations of stability and those kinds of things. And so in order to get a parachain slot, you have to stake certain amounts of resources and kind of buy in to that slot. And then you're guaranteed that shared security for some certain period of time. Maybe you're not able to get one of those finite number of slots, or maybe you don't want to make that commitment. Maybe that's not your business model. And so that's where parathreads come in. It's essentially the same underlying technology that informs the parachains, but the model of shared security from the relay chain is just a different model, a less stable, reliable model, which may be something that you do as you're kind of like ramping up to the full parachain model, or maybe that's just what works for your company or your use case. So that's what this parathread pool is about. And then finally, you see these two boxes kind of off to the side here. Both of these are meant to represent bridges. And so a bridge is what connects some parachain. You're typically, what I have heard from the real core developers that are building all this stuff, is in the wild, it's going to be highly unlikely for a bridge to be connected directly to the relay chain. Most bridges are going to pass through almost like an application layer parachain that will connect them to some other blockchain. So all of these parachains and even I believe the parathreads that are connected to this relay chain, they all have message passing capabilities for free as part of the Polkadot protocol. But if you want to communicate with other blockchains, you want interoperability beyond the relay chain, that's when you can use a bridge. And that bridge may connect to some other blockchain like Ethereum or Bitcoin. That's all being developed, that's all happening. Or maybe it connects to some other network. So I was actually just reading a little something about the Kusama Polkadot bridge. Maybe one day such a thing will exist. And that's what this architecture depicts, but it could also be other types of blockchains. So let's kind of forget about all that. That's a lot of detail about the Polkadot network and the protocol. And we're going to dig more into the Substrate framework for building blockchains. And the reason why Parity is building this framework is because we need a framework for building blockchains, notably Polkadot, Kusama, Rococo, others. And in order to actualize this vision of a multi-blockchain network, we need other people building blockchains too. And so Substrate has definitely been optimized for building blockchains for Polkadot-like ecosystems, but that's not the only thing that it can be used for. It is truly a flexible framework for building blockchains, optimized for Polkadot-like networks, but we're excited to see the other uses. The flexibility is really the main point. We achieve flexibility by use of modular customizable components, which we'll dig a lot more into what that means. And one thing I want to kind of tease right now is something that makes Substrate very unique is that all runtimes for Substrate-based chains are going to be compiled to WebAssembly. So I'll talk a lot more about what a runtime is. It's a very important part of a blockchain, but I just want to kind of make sure we're all on the same page about what WebAssembly is, which is a portable binary format. So you compile code to WebAssembly. You can compile C++ code to WebAssembly. You can compile TypeScript to WebAssembly. You can compile Rust to WebAssembly. But WebAssembly is a portable binary format. So a lot like how you can compile Java and then by way of the JVM, run it on all different types of machines. You compile code to WASM, and then you can run it on all different types of machines. And so for now, I need you to understand that's what WASM is and understand that blockchains have runtimes, and in Substrate, a runtime must be compiled to WASM. And we'll talk a lot more about what that means. But this idea of flexibility, modularity, customizability, and WASM runtimes, this is kind of what makes Substrate. Now we have Frame. So I've already talked about runtimes a little bit. They're clearly a very important part of building a blockchain. And I promise you, I'm going to give you some very clear description of what a runtime is. But because building a runtime is so important, we actually built a framework within a framework to build Substrate runtimes. And we call that system for building runtimes Frame. And so just like Substrate is a framework for building blockchains, Frame is a framework for building Substrate runtimes. It must compile to WebAssembly because all Substrate runtimes must compile to WebAssembly. So just like pretty much everything we do here, it's written in Rust, just like the Substrate framework itself. But I want you to keep in mind that there are people out there that are writing other runtime development frameworks in other languages. So there's a project called LimeChain that's writing a TypeScript assembly script framework for writing runtimes. So what that will allow is all the really, really complicated consensus and networking stuff that can all be in Rust. Just take the standard out of the box Substrate stuff, and then you can use TypeScript, which you may already be very familiar with, to make it pretty easy to write a runtime. So that's the kind of flexibility that Substrate provides. but we're going to talk about Frame in particular. This is the way that we write runtimes at Parity. So one of the things that's very important about Frame is that the modules are called palettes, and a runtime is constructed by composing multiple palettes that all bring their special logic to the table. And so you can mix and match existing palettes, or of course you can build your own. Okay, let's kind of zoom back out for a second. We just kind of got deep into what the runtime may be. And on this slide, we're going to talk about that a lot more. But when you pull down a Substrate project, and I'm going to show you a template project that you can use to get started, you're going to build it. And what you're going to end up with is a blockchain node. And what that node is it's like an orchestration engine that manages all those different modular customizable components that I was talking about. And so let's start talking about those individual components. And now we're going to start talking about the runtime as the first one. So let's ask ourselves, what is a blockchain? It is a mechanism for allowing a trustless, decentralized network of participants to come to consensus on the state of a system as it evolves over time. So let's narrow in on that state of a system. People want to come to consensus on the state of a system. The runtime is where we represent that state, that system. And so as I mentioned, I went to computer science school, and the guys that were teaching me about computer science, they all went to school back in the day, and they would tell me like, oh, we used to have to go to this big machine, and we would have these cards, these punch cards, and we would put the punch card into the machine, the big mainframe computer, and it would be like the instructions that the computer would execute, you know? And so I want you to kind of take that example and think of that big computer as the state machine. It kind of defines some rules, you know, some parameters around which you can tune some variables and some configuration or whatever. And then there's some mechanism by which you can submit some instructions for making those changes. And so the runtime is the big computer. It's basically the rules around which you can change these things. And then a transaction into that runtime is one of those cards that defines like a request for a state transition. And then when you think of a block, what a block is it's a whole bunch of those cards stacked up on one another in a certain order, executing in that order. And then at some point, we want to come to consensus and say this represents a valid state transition, and moreover, the canonical state of the blockchain. So that's what the runtime is it's this engine of state. It's the state machine. And the parameters and the configuration that we talked about, we represent the snapshot, the current state, as runtime storage. And notice that actually the runtime itself, the definition of the rules, is a part of the runtime storage. This is another one of these key critical things of Substrate. And this is all enabled by the fact that the runtime is compiled to WASM. So that's why we compile the runtime to WASM, because we need to be able to compactly and in a non-ambiguous way represent the runtime in a way that we can distribute easily to people. So just like you could update the balance of an account by making a transaction, because all that balance is an element in runtime storage, with the Substrate-based chain, you can update the very rules around which the state exists. You can add new elements to state. You can fix bugs. You can add features. All of that you can do trustlessly and by leveraging the core capabilities of the network itself, because of the fact that we use WASM runtimes and include the definition of the runtime as an element in runtime storage. So that's a lot of the theory and power behind Substrate. So this is all, this storage that I hope I really just helped you get a better understanding of. The snapshot is stored in this performant key value database. So the runtime is part of the node. We just spent a lot of time talking about the runtime. Now I'll spend a much less time talking about all this other stuff. So the runtime and the storage, that snapshot, it exists in a performant key value database that is a part of the node. Right now, Substrate is using RocksDB, which is a Rust database, key value database, highly performant, battle tested, well respected. We are in the process of developing ParityDB, which is a next generation key value database that's building on the concepts of people like RocksDB, but really optimized for the blockchain use case. And again, this is where I'm going to take the opportunity to say that because everything is so well designed and modular, that's possible. We can switch out this underlying storage layer because from the ground up, this has been built in a way that makes sense. So the runtime is built on top of this key value database that can be used to represent the snapshot, the current state of the runtime. And then of course, with the blockchain, we want to, like we said, as it changes over time and have access to some immutable, cryptographically secure history of that state. And so that's what the block database is. But all of this within a Substrate node is implemented on top of the same performant key value database. So this is really the most important part of the node. This is why the node exists. The key value database, the runtime, all of that. And so now we want people to be able to make transactions and make storage. People need to interact with this, and maybe they want to query the state or see what the state is right now. And so that's what the RPC server does. And so requests come in through the RPC server. And if they want to know about the history, we can look into the history of the blockchain and make a query into the blocks. Maybe they just want to know about the state right now. So we just make a query into runtime storage. That's possible too. Or maybe through this RPC server, we want to submit a transaction. And that's actually going to go through the transaction pool. And that transaction pool, maybe if the local node is authoring a block, will communicate directly with the runtime, or maybe for other reasons, we'll want to get some information from the runtime. But the transaction pool is, first of all, it's separate from the runtime, it's separate from the RPC server, and it's also separate from the networking layer. So that's to say that if you want, you can customize the transaction pool all on its own, or you can customize it the networking layer on its own. We use libp2p for our networking layer. libp2p is a battle-tested, well-known multi-protocol networking stack. And so that's what we use to help these nodes gossip transactions across the network. And so the transaction pool is going to send transactions to the networking layer, and then the nodes are going to talk to themselves. So RPC server is how users interact with the node. libp2p networking is how the nodes interact with each other. And that is all separate from the consensus engine. So because we're using this flexible multi-protocol networking stack, you can implement all different kinds of consensus engines, Aura, Babe. Are you going to use a finality mechanism like Grandpa? Are you going to use a different type of finality mechanism? All of that you can customize at the consensus layer. And then finally, through the consensus engine, we're going to come to some consensus over the final canonical block history, like I mentioned. And so then that's kind of how the consensus engine interacts with that. It may be possible to have a non-WASM runtime as like an optimization layer. So a native runtime that is like really useful if you want to sync the chain very quickly. And so that's what this executor does, is it looks and it sees, is there a native runtime? And it makes the decision between native or WASM. And then of course, this is a lot to manage. And so we have a telemetry server. It's an embedded Prometheus server that helps you monitor all this. You get this all for free with this template project that I'm going to show you. So that was a lot. Anthony, do we have any questions that you want to highlight before I kind of move on?
I'm just going to chat now. No, I don't think so. I think we'll wait to the end, really. I think Urban's answering some. Yeah, keep going, really.
Cool, awesome. So that I just covered a lot of stuff, and really I basically covered everything that's on this slide, but let's kind of, we just took a big zoomed out and kind of looked at everything. And so now let's just review the runtime piece of things, because as we said, the runtime is it's really the engine. It's what this is all about. Everything else exists to serve the runtime. So your business logic, that's at the runtime layer. So that's where we focus on for business logic, most of it at least. So the runtime defines the rules around state transitions, and then the APIs, like the functions that underlay the transactions and that define the types of transactions that you can make, those are defined at the runtime level. We persist these to storage as blocks, so we have access to the history. The definition of the runtime is an element in storage. This is very unique about Substrate and enables forkless runtime upgrades. There we go. And now what we're going to talk about a little bit is how we can use the frame system to make runtime development easier. So first thing that we talked about is that frame, like you compose a runtime by combining modules that we call palettes. So some of these palettes may be for like consensus capabilities. I want to take a second to dive into these two right here, the contracts palette and the EVM palette. So when you think about blockchain, you may be very familiar with the idea of thinking about smart contracts. And that's definitely something that Substrate-based chains do very, very well. But it's only one capability that your chain can provide. What is a smart contract? It is a way for a user to deploy custom logic to your blockchain in a way that is scalable and allows you to account for resources. But that doesn't come for free. There's a lot of logic and math and overhead around providing that scalability and security. And so if you don't need to allow people to deploy custom logic to your blockchain, you wouldn't need to have smart contracts on your blockchain. All of your logic would just be baked directly into the runtime layer, which allows it to be much more performant. But let me give an example of, sorry, I'm just gonna pause my video for 1 second. I need to like kind of blow my nose. Let me give an example that I think provides a really good understanding of when it might be a good idea to support smart contracts. Let's say that you wanted to provide a platform. Really, anytime you start to hear the word platform, now, okay, smart contracts really start to become a thing. So let's say you want to deploy a platform for blockchain gaming. So you want to make it easier for other developers to define blockchain games, or maybe even like you define the game, but maybe you want to allow people to define like custom mods. So, you could deploy like some custom modifications. Yeah, that's a great example of when you would want to use a smart contract. And so there is a palette that you basically just get that for free when you use Frame. There is the EVM palette, which implements a full Ethereum virtual machine if you want to use those capabilities out of the box with EVM bytecode smart contracts. Or if you want to kind of start building on some next generation smart contract capabilities, we have our own contracts work palette that uses, no surprise, WASM based smart contracts. Along with the EVM palette, there's this project called Frontier that provides a lot of the RPC layer and consensus layer support that's needed to let developers work with things like Truffle and Remix. So there's a project that you may be familiar with, Moonbeam. It is a substrate-based chain that you can essentially take any Ethereum project today and drop it into Moonbeam and get Truffle and Remix and MetaMask and all of that stuff for free. And that's because of the work that's already been put into the EVM palette and Frontier and other things like that. So I hope that helps you understand why smart contracts aren't the be all and end all of the Substrate ecosystem. There's a lot more that you can do. So let's say that you just need multi-signature capabilities. There's a palette for that. You deploy that right into your runtime. Yesterday, I noticed that we have elections on here twice. That's because governance is like actually so, well, it's actually because it's a mistake, but let me try to do a little spin on that. It's because one of the things that Frame does so well is governance. I talked about not just technical scalability, but kind of squishier aspects of scalability, the human aspects of scalability. So I hope I already helped you understand the technical capabilities that allow a forkless runtime upgrade to happen. But now there's all kinds of questions like who makes that transaction and how do we give that person access to making that transaction? And how do we account for that? And I mean, it's with great power comes great responsibility. And so with the Frame framework, you get a lot of governance capabilities for free that you can use out of the box or tune to fit your needs. And so let's talk a little bit about what's in a frame. That's my bad developer humor. I think Shakespeare said, what's in a name? So we're going to talk about, what's in these frame palettes. How can you use existing frame palettes, or how can you write your own to encapsulate your own blockchain logic? So as you see here, a runtime is a lot of different palettes. And sometimes these palettes need to kind of talk to one another. The outer runtime, that's what we call this, like kind of the concept of all these palettes in aggregate is the outer runtime. Sometimes you need to get some info from the outer runtime into the palette, the inner runtime. We don't really use that term inner runtime. It's more like the palette. You want to get it from the outer runtime into the palette. And so we have this trait configuration interface, which I'll show you some code in a little bit, but this is what enables you to do this. So let me put this into a clear example for you. Let's imagine that we're talking about the contracts palette. You need some way to pay for gas in smart contracts. That's a thing, EVM, even our contracts palette, we have like gas. And so you need to have some understanding of currency. And so there are different palettes that encapsulate different currency capabilities. And so when you're implementing the contracts palette for your runtime, you need to plug in that currency capability. And your runtime may have multiple different currency capabilities. Maybe you want to use one currency for the consensus, and maybe you want to use another currency for smart contracts. All of that is possible with Frame. And the way that you would do that and configure it all is through this trait configuration interface, which is one part of a palette. I think we really talked about how storage is very important to blockchains and runtimes. So of course, the palettes have all kinds of abstractions around storage mechanisms and making it easy to define them and work with them. Then I'm going to skip ahead. You have these like dispatchable transactions that allow you to modify storage, and maybe it conforms to the rules and maybe it doesn't. If it does conform to the rules, you emit an event, which you define at the palette level. And if it doesn't go the way that you want, it doesn't conform to the rules, you emit an error, and you can define those at the palette level as well. And then palettes can define interfaces to talk with one another. So there's these dispatchable transactions that allow off-chain interaction with the palette, but maybe palettes want to communicate with one another. And so that's what this public interface is. Dispatchable transactions are for off-chain interaction. Palettes can also do inter-palette interaction. And then in addition to all this stuff that's kind of like going on at the palette level, there's some other primitives that Frame defines, like the idea of an origin, which allows you to do access control at the palette level. I asked about like, how do we decide who can make the transaction that updates the runtime? The Frame way of answering that question is with the origin primitive. Another thing that helps answer that question in the framework is how we version our runtimes. And so there's a specific Frame definition of a runtime version that kind of exists above the palette level. So the heart of Frame is the idea of composing a runtime through multiple palettes, but there's other things that kind of exist to help it all work together. All right, so we're going to look at some code now, basically. I already shared these slides with you, so you should have access to all these links. We'll share it again at the end. Let's see. I'm going to share this resource right now, Awesome Substrate. I hope all my developer friends are very familiar with Awesome repos. So let's see, how do I get to my chat here? There we go. I'm going to share that for you. But next, let's go look at this node template. I told you that we have this node that's like a fully functional blockchain. And so let's take a look at this palette. I'm going to show you what one of these looks like. If you go and look at this node template, which is of course linked to off the Awesome Substrate repo, there's a whole thing that goes through the template structure, but we're going to walk through that a little bit right now. So I'm going to show you all the different things that comprise this node. One of them is a template palette that kind of shows you the skeleton of what a palette could look like. So this is that trait configuration interface. Because we don't have a ton of time today, I'm not going to get real deep into the Rust syntax. Please ask me lots of questions in our technical chats. I can help you answer them there for sure, or maybe share some links with you that can help you answer them. But this is in the code, that mechanism that allows you to wire up your dependencies. So we talked about the fact that your palette may want to emit emit events. And so that's kind of this thing that like your runtime and your palette needs to share some idea of what an event is. And so in order to provide your palette with the capability to emit events, you need to configure that by way of the trait configuration trait. Like I said, if this were the contracts palette, you may have a type of currency here that you would configure. But for now, just bear with me and keep in mind that this is what the trait configuration trait looks like. And this is how you kind of hook all your palettes together. This is what storage declaration looks like. This is a Rust macro. That's what this is. A Rust macro is code that writes other code. So essentially what that means is it's a programming language. At the time that you start writing a macro like this, it's really almost like another programming language. And so because Frame does make such heavy use of Rust macros, I do think in some ways it's productive to think of it as a programming language for writing substrate-based runtimes. And just like JavaScript or C# or Rust has data structures and primitives for like hash maps and lists and all that kind of stuff, Frame also has those primitives, and they would all be defined within like this decal storage area. You can read more about it by following this comment. What you see here is a very simple example of just defining like one single storage item as opposed to like a list or a map. This is an unsigned integer, but there's lots of examples of doing more complicated, interesting types of storage. Events are just an enum. It's another type of macro, but at the end of the day, it's just an enum. So basically you define like all the types of events that could happen, all the different types of interactions that your palette defines. Errors, same idea. It's an enum where you define all the different things that could go wrong. And then finally, decal module is the macro where you define the functions that sit underneath your transactions. So again, this is all kind of very silly. We'll actually take a few minutes to look at some more serious examples, but within the palette template, this is where you can start playing around to define your own custom transaction logic. So this is what a palette looks like. Let us now go and see how the runtime composes all of these palettes. Gonna scroll. Is that still? Yeah, I think that's still good. Okay, I'm gonna scroll down a little bit. So you see we have this construct runtime macro that is taking all of the palettes. And so whenever you're looking at a frame runtime and you want to say like, okay, what are the capabilities in this runtime? What does it do? You come and look at construct runtime and you see all the different palettes that are in there. And so you can see, for instance, that the template palette is part of this runtime. And in order to include these palettes in your runtime, you need to implement the palette. So this is where you hook up the configuration trait that I was mentioning. And so, like, for instance, one type of logic that we have encapsulated in a palette is transaction payment. And so just like with smart contracts, you need to know about the currency that you're using to pay for things. If you want to include our transaction payment palette in your runtime, you need to configure the balance that you're going to use. And so now let me start to show you like a little trick of how you start to navigate this code. I now want to say, okay, so maybe I want to write a palette that needs to know about a balances type. So, okay, the transaction payment palette does that. I can see here that the transaction payment palette currency type is set equal to this balances thing. Okay, let me do Control F and let me Google balances and see what else I can find. Oh, there's this palette balances, which makes a lot of sense. There's this palette that provides us with currency capabilities. And you can go and look at its documentation, you should, but you can even just start to get a sense of what it does by looking at its trait, configuration trait. So unfortunately, I wish we could write code today, but I hope you can start to understand why there's kind of like a lot to talk about before you can really start to dig in. I want to give you all these little pro tips that you need to hit the ground running and be a good coder from the beginning and minimize your frustration. So that's how you start to look at the runtime for a frame node. And now the last thing I want to show you is some of the stuff in the node library. This is where like RPC, CLI parameters, consensus can live here because the node template makes use of so much of the default stuff included in Substrate. There's not a lot of code here. It's all kind of hidden underneath the libraries. Which is great because in most cases, it works awesome. We believe that in most cases, many cases, you won't need to modify this stuff. If you do need to modify it, you can. One of the most common things that you'll want to modify is the genesis state of your blockchain. Like a very understandable thing, I think, is like who what are the accounts that you're seeding with a large amount of tokens to kind of get things started. And so Frame provides some easy ways to do that. You can see that we're configuring each one of these palettes with some set of parameters that define the initial state. And so here we're endowing some accounts with a large initial balance. So we must be calling this function with some vector of accounts. So let's go look at that. I mentioned that there are different parameters that you can use to start the node. One of the ones that I hope you become very familiar with is --dev that you use in development. And so that's going to invoke this function right here. And so it's going to pre-fund these accounts with large amounts of currency. And if you want to add more accounts, this is the chain spec file where you would add those other accounts right here. So this is kind of the last thing I want to show you in the node template. Let's go back to the slides now. Okay, recipes. Well, before I go into recipes, you should all definitely check out substrate.dev. And in particular, I want you to check out our tutorials. I won't share that link for you. It's pretty easy, substrate.dev, and then you go to the tutorials. And I think if you really want to get started like really quickly, or maybe not necessarily really quickly, but what I would consider the best way, you want to do these 4 tutorials here. This is really going to give you like the best understanding of Substrate and Frame. So in this tutorial, you'll get your development environment all set up with the node template and everything. In this tutorial, you'll add a new pre-built palette to your runtime. In the 3rd tutorial, you're going to start to learn more about building your own palettes. And then in the 4th tutorial, you'll actually do one of these forkless runtime upgrades and tie a lot of stuff together. So I think if you go through these 4 tutorials, you're off to a really good start. After you do that, you may have some things that you want to do, but you don't know how to do them. And that's when I would recommend that you go to the recipes. So you can go either from the slides here, I have the recipes, or they're up here on substrate.dev. And recipes are where you'll find a lot of code that we've put together for you for common problems. We know that this code compiles. We think that it works pretty well. It may not be like for production in all cases, but it'll definitely kind of help you get going. There's a front end template to help you learn how to write front ends, and kind of it provides a minimal working application, just like the node template is a minimal working blockchain. You'll learn all about the front end template actually in the very first tutorial. You'll get that set up on your computer and start interacting with it. But the very last thing that I want to show you, some other like pro tips for working with Substrate. Let's say that you want to just learn more about Frame, or you have some specific questions. You want to see how we do things. You should check out the core Frame palettes, like some of these ones like balances and consensus that I was telling you about. So the link is here in the slides. It's part of the core Substrate repo, and you can go and look and see what it looks like, how these palettes are built, and start seeing how the Substrate core developers do things. So I definitely encourage you to use the Substrate code base as a resource itself, and start digging into this and seeing how things are done. And so this is going to be really helpful when you want to potentially understand how palettes work, or maybe write a palette of your own. If you want to add a palette that already exists to your runtime and you want some helpful examples of how to do that, there's this example node where there's a link right here, but I'll just show you how to get there from the Substrate repo, because I want to help you feel comfortable navigating Substrate repo. You go up here to the root, there's this bin directory, and you go into node. You'll see here there's actually node template. This is where the node template repository that we were looking at comes from. But let's look at this big node that ships with the Substrate repo. will go into the runtime. The lib is like the main in Rust. And this runtime, unlike the node template, it includes the contracts palette. And so maybe you want to learn about how you would add the contracts palette to your node. So you can come and look and see how we did that. And you can see, just like I said, we're providing it with an idea of currency. So that's kind of, I guess if there's one more resource that I want to make sure you know of, from substrate.dev, you can go to the API reference. Unfortunately, I'll keep it real with you, our search capabilities on substrate.dev aren't as great as they could be. We're working on that. The Rust docs have really good search capabilities. So let's say you want to learn more about that balances palette. You can come in here, search for balances, go to palette balances, and then our core developers, they write all this documentation. It makes my job so easy. You know, amazing documentation here that tells you all about the palette, how to work with it. So yeah, those are like my pro tips for you. I showed you substrate.dev already. The developer hub, GitHub organization is where you can find like awesome Substrate, the node template. We got some upcoming events coming up. Get in touch with me. And yeah, I'm happy to check in and see if there's any questions now, Anthony.
Very goodly. I think we'll leave questions on chat just because it's quite complicated to let people to unmic themselves. So Hector says, "Oh my, such a good presentation." What's
Thank
this?
you.
Try to see. I think some of the questions have been answered. Really, what am I missing? A lot of it answered during it. Anyone got any questions for Dan? Speak now. It's always the awkward moment where you ask people if they've got questions. We'll give people 30 seconds.
It's much more awkward for me, you guys, if no one asks questions. So it's like I'm like Tinkerbell over here. Like I need you to like, you know, make me real by asking me questions.
Like Tinkerbell.
That's not, yeah, the hat is not the only thing I have in common with Tinkerbell.
Outstanding. Is there any recommended resources to learn Rust? There's a couple of questions coming in. So first, is there any recommended resources to learn Rust?
Yes. So the Rust community is fantastic. And that's a really good question. People often feel like they may need to wait to learn Rust before they learn Substrate. I wouldn't necessarily encourage you to do that. Like I said, in some ways, it's almost like its own programming language. So I think you can kind of start learning Rust, especially if you're already maybe have like a year of programming under your belt. You can start learning Rust by virtue of learning Substrate. At some point, you're going to want to dive a little deeper into Rust proper. And if you go to rustlang.org/learn, I think they have amazing resources. I'm actually going to stop sharing my screen so it can be a little bit more human now. Yeah, rustlang.org learn, or just check it out. There's like the Rustlings course on GitHub, which is really, really fun. It's like a gamified guided learning experience. There's the Rust book, which is very, very well written. And then there's a Rust playground. So a lot of great resources for learning Rust. Good question.
Great. You mentioned Grandpa and Babe. What is the difference between those two?
Yes, I'll do my best. So these are finality, these are consensus mechanisms that are written by PhDs. I am not a PhD. I have a bachelor's degree in software engineering or computer science even. So Babe is a consensus mechanism that unlike Aura, which is, I believe, proof of authority, it uses a well-known centralized set of authorities. Babe is decentralized. It's what allows us to implement like nominated proof of stake, I believe. So it's the block authorship consensus mechanism. Grandpa is a finality gadget. So all blockchains are going to have a consensus mechanism, but I believe that like most proof of work chains use like non-deterministic or probabilistic consensus. So you may be familiar in the Ethereum ecosystem, like, oh, you have to wait some certain number of blocks before something is considered final. That's probabilistic finality. Essentially, there's some heuristic where people say, like, it's very infeasible that after this number of blocks, a malicious validator would be able to come along and rewrite the blockchain. And so that's probabilistic finality. In Substrate, you may or may not decide to add a deterministic finality gadget, such as Grandpa, into your consensus mechanism. And so that's what Grandpa is. So Babe is kind of at the level of providing probabilistic finality, and then Grandpa is an optional finality gadget that you can throw on top of that.
Good. What else? Mork says he got his node working.
Awesome.
What's the motivation for parachains to have their own consensus like Aura and POS? Can you plug your parachain into Polkadot without it?
This, I would say, is probably where I mostly get out of my depth. As I mentioned, mostly live at the runtime level. I know that there are definitely like compelling reasons for implementing different types of consensus mechanisms, but at this time, it's just not the kind of thing that I'm the right person to answer. I can help try to get you those right answers. And I know that right now, the frameworks that exist around writing parachains support a fairly limited set of consensus mechanisms, but the goal is to expand that set as much as possible while still being stable and secure and all of that stuff. So there's a relatively limited degree of flexibility around that right now, and we're working to expand flexibility very much so. We have a technical chat channel dedicated to this. It's called Rococo. So let me drop, I mean, the name is great. If you love my hat, you're going to love the name of the Rococo test network. Cheers to the people who came up with that. But what I'll just start out with is dropping a link to our technical chat. Come and talk with us, and then that can kind of be your portal into these more specialized chats, like for parachains, smart contracts, all that kind of stuff.
Cool. What should we go? Can you tell us more about parachain, like how other chains could communicate, trade, or transact with it, if possible?
Yep. So this is all baked into the Polkadot protocol. The vision is what we refer to as XCMP, cross-chain messaging protocol, and this will allow direct parachain to parachain messaging by way of the shared infrastructure of the relay chain. What we have implemented and working on our V1 Rococo testnet right now is what's called HRMP, horizontal message passing. And this is where the parachain sends a message up to the relay chain, and then from there over and down to the other parachain. So let me provide you with a place where you can learn more about this. I'm going to send you a link to a specific section of the Parachain Implementers Guide that focuses on the messaging protocols. But if you want to get really, really deep into what the Polkadot protocol is and really what gets way out of my depth, check out the Implementers Guide. That's where all the really cool work is happening.
Very good. Any other questions, everyone?
Great question.
What's the difference between parachain node? What's the difference between a parachain node and the collator? Are they running with the same code? Also, you mentioned the storage and the ROCs database. Are all of the data, or is all of the data being shared amongst the nodes?
A collator is just jargon for the parachain node. It's really just another type of jargon, and it's to distinguish it from the fact that they are technically different from the validator nodes, which are the relay chain nodes. So it's like jargon, shorthand, collator, parachain node, validator, relay chain node. The storage is not shared amongst the nodes. Each node has its own database, and some nodes may be running in archive mode where they have all of the block history, or other nodes may be running in like a restricted pruning mode where they have a much less blockchain history. So the underlying storage itself is not shared. It's not distributed storage. Each node has its own copy of storage, and there's cryptographic protocols and consensus mechanisms that allow them to trustlessly come to consensus on this state. So very good question, because it really speaks to kind of the heart of what we're talking about here. I hope I did a good job of explaining that.
You did. Any other questions, guys? Any other last questions, comments, things people want?
Thanks for including us in this event, Anthony. I mean, I was really excited to learn about it and everything that y'all do with Encode. And
with us.
yeah, I can't wait to like see what comes out of this. And I really hope that you guys ask me lots of questions that make me feel dumb and that I'm not able to answer. Nothing would make me happier. I will gladly hand you guys off to the right people that can help you answer these questions. And please join our technical chat. Everyone up to and including Dr. Gavin Wood participates in that channel. So yeah, like I said, we're not just the creators of kind of really cool, dorky technologies. We're also stewards of a really exciting ecosystem that I'm really, really proud to be a part of, really proud to participate in y'all's. So yeah, thanks for having me, Anthony.
Well, Dan, thank you very, very much. And to everyone who attended today, thank you very much. All the slides and video will go up later tonight. And yeah, okay, cool. Sorry, someone was messaging that. So thank you all for coming. We'll upload everything. There is another picture.
Do any last minute questions in chat, and yeah, happy hacking, guys.
Awesome. Next events, we've got a few events next week. Introduce blockchain on the Monday. Oh, there is another question. What would be the case to have a custom runtime origin?
Okay, I can talk about that for a second. So the most common origin is the signed origin. That's when someone makes a transaction to your blockchain. And so then you can inspect that signed origin and actually see the identity of the signer, through cryptography and everything. There's another origin, which is for block authors who want to insert data into a block, not by way of a transaction, but just by way of their block authorship mechanism. That's another type of origin. There's another origin that Frame defines that is it's called the root origin. And it's the concept of the system administrator. And so that is the origin that's allowed to do the runtime upgrades. And then another reason that you may define a custom origin, really, really good question, is for governance. So let's say that you have some governance body that there are votes, there's proposals and votes that happen. And maybe you want to set an origin for when a proposal passes by 2/3 versus a different type of origin for when that same vote passes unanimously. Frame would allow you to identify those two different governance ideas using the origin primitive. And so then you could create runtime logic where a unanimous vote is fast-tracked and it happens immediately, but a 2/3 vote requires some vesting period or something like that. But I mean, I hope that I've just made you go crazy with ideas of all the different kinds of things you can do with these origin primitives, because it is one of the most fundamental, powerful Frame primitives.
Awesome. All right. Thank you very much, everyone. Events next week. Interest blockchain on the Monday. We've got Binance on the Tuesday, Teller and Raiden on the Wednesday. Thursday's Thanksgiving. I think Polkadot we have scheduled for Tuesday, the 1st of December, which is amazing. We're coming into December so fast, only 10 days away.
Unreal. And next time I'm going to try to, we'll dive a little bit more into writing some code. So hope to see y'all there.
Okie doke. All right. See you all soon. Thank you very much.
Thanks, Anthony. Bye-bye. Had a lot of fun.